Hey everybody, welcome to the next video on the square roots and Pythagorean theorem unit called right triangles, where we start to explore the idea of right triangles and introduce the elements of the Pythagorean theorem. So let's move forward. We're going to try to make this a 10-minute video or so, starting to look at a right triangle here. So if you look here at these sides, you'll see that there's one long side and then two shorter sides. The two shorter sides we call legs. The longest side is called the hypotenuse. It's a funny name. It's like hippopotamus, hypotenuse, I don't know. Hypotenuse. And you'll usually call it C, and the legs will be A and B. The important things to remember about the hypotenuse are, first, it's always opposite the 90-degree angle. This box here means 90-degree angle, so the hypotenuse is on the other side. The biggest angle is across from the biggest side. Important to remember. And it's also the longest side. So when you're looking for hypotenuse, or you're trying to put one in a triangle, it will always be the longest side. Okay, this graphic here, what I'm trying to do is I'm trying to show you that if you count out all these boxes, this is a 6 by 6 and this is an 8 by 8. If you count out all these squares in a right triangle, they will add up to all the squares on the hypotenuse side. So all the two squares that we make out of the two shorter legs will add up to get the big square that the hypotenuse makes. And remember, by square, I'm actually talking about, yes, actually a square. When you square a number like a, let's say a was 2, or in this case, it's 6. If I'm squaring 6, it's 6 times 6, so it's actually producing a square. 6 times 6, and that fills out all the area inside. 8 times 8 fills out all the area in between those. So adding these two areas up will get me this bigger area. These other ones, I'm not so sure whether they are right triangles. And the graphic that I have here, I didn't actually finish it, but if they were, I know this one is not. So I've actually done this one. It's 25 squares. This is 25 squares, and this is what's left over. 49 doesn't quite match up. This is not a right triangle. And this one, I think I actually messed it up a little bit. It's supposed to be 5 times 5, so this should be filled out. But it seems to be missing a little bit more. So maybe it's not exactly a right triangle, or is it? I don't know. I'll leave that to you guys if you figure it out. I should have finished that off, but anyway, it might actually be a right triangle. But the important thing to remember here is it's a right triangle if this and this add up to get this. In this case, it does not add up to get this, so it's not a right triangle. This one it is. This one I can't remember. I didn't really want to finish that. That was a lot of little squares. Okay, you're going to have a document that looks like this. Except it won't have the numbers in. I put the numbers for you, but I want to talk about them as we go through. The point of this was to use the information that is on your screen to determine whether it's a right triangle and to find the rest. I'm not too worried about the angles. So this stuff we don't really have to worry about. You can just write it in. But just looking at these, you have the side lengths, 6, 8, and 10. You should be able to identify that 10 is the hypotenuse because it's the biggest side. And the important thing to remember is it's a right triangle if the squares of the two smaller sides add up to produce the square of the biggest. So 6 squared is 36, 8 squared is 64, 36 plus 64, yes, they add up to be 100, so it is a right triangle. But look at this one, 5 squared, 7 squared, and 10 squared. 5 squared is 25, 7 squared is 49, 10 squared is 100. These do not add up to get 100, so it's not a right triangle. That's important, especially for later. Okay, here's a question for you. For the two right triangles, what do you notice about the areas of the squares on the legs in relation to the area of the square and the hypotenuse? It's a lot of words. But basically the question is, for something like this, what do you notice about the small triangle and the medium triangle compared to the big triangle if it was a right triangle? And the answer we've talked about a few times already. The sum, so adding the two small areas together, will give you exactly the large area if it is a right triangle. I'm going to put a link to a nice little Pythagorean in 2 minutes video that's pretty good at showing you how that kind of works. So I do want you to watch that. It takes 2 minutes. It's worth it. You should watch that and then come back here. All right, a couple questions, and we'll go through these as quickly as possible because they're not really too bad. So what is the area of each square? So remember that P, the side P here, is 3 centimeters. Q is 4 centimeters, and R is 5 centimeters. What we've done by creating these square is we're saying that 3 squared, 5 squared, and 4 squared produce areas. So 3 squared is just 3 times 3, and 3 times 3 is 9. So that's 9 centimeters squared. 4 times 4, or 4 squared, is 16 centimeters squared, and 5 squared is 25 centimeters squared. So that's the answer to these. Which side is the hypotenuse? Well, that one should be easy. It's opposite the right triangle, and it is the longest side, so R is the answer there. Write an addition statement showing the relationship between the areas of the 3 squares. Well, the area of P, so the area of P, that's what I'm writing here, area of P plus the area of Q is equal to the area of R. And if I put that in terms of numbers, then what we have here is area of P is 9 centimeters squared plus 16 centimeters squared is equal to 25 centimeters squared. Okay, that's the addition statement. Now describe using words. I'm not going to write it out because my writing's sloppy tonight. But basically, what we're trying to say there is the sum of the squares of the two smaller sides, so side P and side Q, the sum of these squares, this square plus this square, equals the big square, or the hypotenuse. All right, show you know. This is one for you to do, but I'll help you out a little bit. So first we sketch a triangle. It's a right triangle, so I have that square there. The hypotenuse is the biggest side, so that's 15. 15 is going to go here, and it doesn't really matter where 9 and 12 go. Let's say they go here. You don't have to draw all these lines. I'm just kind of showing you where they go. So you sketch a picture and you draw a square on each side. So if I square this side, which I said was 9, then it would stretch out like this, and it would be a 9 by 9 square. This one would be a 12 by 12 square, and this one would be a 15 by 15 square. Hopefully your picture is quite a lot less messy than my thing here. After that, you're going to find the area of each square. So what is 9 squared, what is 12 squared, and what is 15 squared? Then you write an addition statement that uses the areas of the squares, just like we did before. Remember, the sum of the two smaller squares makes the big square. I probably should have told you to pause the video, but here we go. 12, 9, and 15, as I wrote there, I did the squares. 12 squared is 144, 9 squared is 81, 15 squared is 225, and the addition statement I was talking about before is 81 plus 144 equals 225. You could also write, it would also be appropriate to write 9 squared plus 12 squared is equal to 15 squared. It's really the same thing. It's just that the other one you actually did the square. Okay, triangle with side lengths of 5, 7, and 9. So we have triangle with side lengths of 5, 7, and 9. 9 is my biggest, so it'll be my hypotenuse here, 9 centimeters, and I'll say this one is 7 centimeters, and this one is 5 centimeters. The question is, what are the areas of the 3 squares that can be drawn on the side of the triangle? So if I make a square out of this, it's a 7 by 7 square. What a messy drawing here. Why am I doing it like that? I'm so messy. Oh, God. All right, 7 times 7 is 49. So the area would be 49 squared. The area of this square would be 5 squared is 25 centimeters squared. And this one is 9 squared, which is 81 centimeters squared. Is the triangle a right triangle? Now, to answer that question, I have to use the Pythagorean theorem, and to do so, I'm going to remember that the sum of the two smaller squares, so 25 plus 49, equal 81. So if this is true, then it is a right triangle. If it's not true, it's not a right triangle. So let's take a look. 20, oh, where did my calculator go? I didn't even notice that. You're looking at all these funny videos of the Pythagorean theorem stuff that I've been working on. Okay, let's put the calculator back in its place. Here we go. And let's try this out. So 25 plus 49 should be 81. If I hit the button and it's 81, then we're good with a right triangle, but it is not. It is 74. And sorry, but 74 does not equal 81, so no. The answer is no, it is not a right triangle because it does not fulfill the Pythagorean theorem. Sad face. All right, show you no. So here's one for you. I'm not going to start you off on this one. You should be capable of drawing a triangle and figuring out the sides and making squares out of those at this point, and determining whether it is a right triangle by using the Pythagorean theorem. So I would like you to pause the video now and give that a try, and then come back here and we will check your answer. Okay. Here's what I got. So my triangle, I have 16, 12 as my legs. Hypotenuse is 20. The squares here, so the area of side A is 16 squared, which is 256. The area of side B is 12 squared, which gets me 144. And then side C is 20 squared, which gets me 400. Now, when I use Pythagorean's theorem, 256 plus 144, so these two should equal this one. And yes, they do. So correct. It is a right triangle. Congratulations. You have made it through this video and you are ready for the next one.